All right, so this is the reorg script that we used. Hadoop is all text-based. Most everything you do with it is all just giant text files. So awk is really useful, and it's really easy to write. There's 3 lines of code that reorganized our entire 17,000 files, and then it was real simple to just dump them all into 100 files. So the efficiency gained by reorganizing, this is for Netflix One, which was one of the smaller programs that we wrote. It took 43 minutes and 27 seconds to run with the default data set. Just by reorganizing the input data set, you can see a 400% increase in efficiency. And then you have Python running it still faster than the original data set and awk. And we'll talk a minute about Python and awk, how they incur a bunch of overhead because they use the streaming interface, whereas the Netflix One reorg was implemented in Java, so you don't have that overhead.
So the first program we wrote for Netflix was a program to produce statistical information about each movie in the dataset. I took every movie from the reorganized dataset and we produced the first date rated, last date rated, the total rating count, and the average rating for each movie. So as you can see, we took the reorganized training set and we outputted movie ID as a key, rating and date rated from the mapper. Produces 1 key value pair for each individual movie rating. So for each customer rating that they rated a movie, it produces 1 key value pair for under a movie ID key. And we're going to pull up some code right now. Here's what a mapper looks like in Java.
Alright, so here's a mapper that I wrote in Java for Netflix One. And all this code's available on our website. You can see I normally don't do this much commenting, but it helps when you have no idea what's going on like we did when we started. And there really wasn't any sample code on Hadoop out on the internet when we started. We just kind of tried it and figured it out. So your input comes in the string variable. You get a line. Everything in Hadoop, when you pass something to a mapper, it breaks on a line break, and so you get single lines out of the text file that get passed to your map method. So you want to write your map method to deal with single lines of your input data set. So you have to make sure that your whole input data set is schemed out so everything you need is line by line. Then you just make a tokenizer. We tokenized on comma because the Netflix data set had all the values separated by comma. And then you can just iterate through and grab all of the different tokens, put them all in individual variables. And so you can see we took the, okay, so you take the name, which is the movie ID, which is off the first line, and we set that to our key for our hash map here. You use output.collect to pass your hash maps out of the mapper into the reducer, and then your value is this rating and date variable, which took the next 2 tokens out of the data set, so the rating, comma, the date, dumped them into one variable, made that the value for each movie ID.
And here's what that same program looks like written in Python. Python is a little bit different because you're using the streaming interface. So basically, I wrote a method to read the input. You get your input basically as standard in. It's basically just the whole file. So I wrote a generator to go through each line of the file and just yield 1 line at a time. And right here you can see I just pass in sys.standardin to my read input function, so I get 1 line at a time. So 4 line in input. Basically split it by comma again. And right here I'm just checking to make sure I have the right amount of values. And the key is going to be your movie ID, and you get the rating and date from the line split. And same thing right here, you print string, tab string, you pass in the movie and the value. And after every line, you have to print a standard error, report.counter, Netflix One mapper, comma 1. Now it gets real crazy when we do it in awk.
Okay, so what we should have explained before those last 2, the standard data set has the movie ID colon on the first line, and then the whole rest of the line is user ID, rating, date rated. What our awk the reorg script did was took that movie ID from the first line and added it as a first token to every line after that, and got rid of that first line. So every line was now movie ID, comma, user, comma, rating, comma, date rated. And you really have to do that with streaming, because streaming you can't access other lines in the file. You're taking input from standard in. And here was the last two files written in AWK as a mapper, because we had AWK locally executable on each of the mapper nodes. So we have two lines. Let's tokenize on a comma. Print 1, tab, 3, 4.
Here's some mapper comparison times. Java averaged 8 seconds a node, or best was 8 seconds a node. It averaged 12. And Python and AWK, they incur a streaming overhead because streaming has to basically add all these functions to translate MapReduce job into standard in and standard out. So you can see Python really doesn't do that great compared to Java, but AWK, since it's a really fast executable, best was 9 seconds, average 15. So you can see that 2-line file is pretty comparable to that large Java file that you saw. And another thing is, really good trade-off between streaming is, as you saw how small those files were, we can write a mapper in under a minute compared to Java, where we have to sit down and take maybe an hour to write a mapper. So if you just have a job that you just need to get out the door, and you don't care about the extra couple minutes of efficiency, you can write a mapper and reducer in just a couple minutes and get your job in and out the door, and that's really the big trade-off for using streaming.
All right, so then we wrote another algorithm called Netflix 2. Calculated a lot of statistics based on the users in the data set instead of the movies, which was Netflix 1. The Netflix 2 mapper output was user ID. Yeah, user ID was the key, and then the value was movie ID, rating, date rated as the whole value. And we added in colons to separate them, so all we have to do is tokenize on colon to separate all those values. Actually, that's the output from the reducer. In the mapper, if you'd output that, you would just tokenize on colon. So you have one key value per unique user ID, movie ID, rating. So you get this huge hash map of the output of all the statistics based on each user, which was user ID, and then the value would be the rating count, the average rating, the rating delay, and the movie rating date list. So when you're outputting in the reducer, everything that passed from the mapper, which was mapped by user ID as your key, your reducer gets a whole array of all the values from that specific user, all the movies that they've rated and the dates that they rated it on and the ratings that they've given it. And then you can, in your reduce method, do all kinds of averaging because of the recursive nature of it. So here's a Java reducer for Netflix 2. Okay, so you declare these variables up here. This is inside your reduce method. You have a rating total, a rating count. String line is your input. Okay, so while values.hasNext, this is iterating through that array that you get for all of the values from a common key. Tokenize it, split it out by commas, pull all the values out and assign them to variables. You add the count, so each time reduce is called, it's going to increment the count. So at the end, you get the count of how many times reduce was called, which was how many times a movie was rated, how many movies were rated by a single user. And then rating delay was just something we did to compute the date that the movie came out and the date that the user rated it, so you could tell if users liked old movies versus new movies based on their total average of the rating delay.